Today I am discussing on magnetic field due to a long state conductor carrying current. This is very important for different examinations. First we draw a diagram. This is AB is a wire, that is current is flowing from A to B. External point, that is P. From O to P, the distance, that is A. We consider a small segment, that is DL. The distance between O to DL, that is L. We consider that is phi angle. Phi is the angle between R and DL. So we have to solve with the help of Biot-Savart law. First we have to write down some points. Let AB is a long straight conductor. The current is flowing through it from A to B. We consider an external point, that is P from O. The distance between them is A. Let we consider a small length DL. The distance of DL from O is, that is L. Phi is the angle between R and DL. Phi is the angle between R and DL. So according to Biot-Savart law, so that is the magnetic field at P due to DL is, that is dB equal to, we can write dB equal to mu 0 by 4 pi, dB equal to mu 0 by 4 pi I dl sin phi by R square. So this is equation number, that is 1. From diagram in this area that is in this triangle, that is 180 degree minus phi. This is theta, this is 90 degree equal to 180 degree. So we get phi equal to 90 degree plus theta, taking sine on both side. So sine 90 degree plus theta, so sine phi, that is cos theta. So next from picture we get that is a by r, that is cos theta, 1 by r equal to cos theta by a, squaring both side, 1 by r square cos square theta by a square. Again tan theta equal to, we get from the picture, that is L by A. So L equal to A tan theta, dl equal to A sec square theta d theta. So putting the value in equation dB, we get that is dB equal to that is mu 0 by 4 pi into I, mu 0 by 4 pi into I, that is A cos square theta d theta into cos theta into, that is cos square theta by a square. So dB equal to mu 0 I by 4 pi, this is A, and cos theta d theta. This is now for AB conductor, that is B equal to mu 0 I by 4 pi A, that is cos theta d theta. We have to put the limit, that is minus theta 1 to theta 2. So B equal to mu 0 I by 4 pi A, that is sin theta, so minus theta 1 to theta 2. So B equal to mu 0 I by 4 pi A, this is sin theta 1 plus sin theta 2. This is the required equation. Next we have to know, that is condition 1. Condition 1, for infinite conductor, that is theta 1 equal to theta 2 equal to pi by 2. So we can write that is B equal to mu 0 I by 4 pi A, this is 1 plus 1, so mu 0 by 4 pi to I by A. So this is very important equation. With the help of this equation we can easily calculate different types of numericals. Next, come to the numericals. So this is a numericals. That is calculate the flux density. Here we get that is B equal to, that is mu 0 by 4 pi, that is 2I by A. So here that is R 0.06 meter is given and I is given, that is 9 ampere. So B equal to 4 pi into 10 to the power minus 7 by 4 pi into 2 into 9 by 0.06. So calculating, we get the value that is 3 into 10 to the power minus 5. Hence required flux density, 3 into 10 to the power minus 5 Tesla. This is very important. Next numericals, I come to the next numericals. This is given. Here we have to calculate the I. So we have to use the same equation, B equal to mu 0 by 4 pi, that is 2I by A. So B, that is, this is 10 to the power minus 7, that is 2 into I, that is distance 0.02. So by calculating, we get the value that is I equal to 32. Hence current through a state wire, that is 32 ampere. Next numericals, here B have to calculate, that is A 0.01 meter, I, that is 2 ampere. We get, that is B equal to mu 0 by 4 pi 2I by A. So B, this is 10 to the power minus 7 into 2 into 2 by 0.01. So by calculating this, we get, that is 4 into 10 to the power minus 5. 4 into 10 minus 5, that is the hence strength of the magnetic field is 4 into 10 to the power minus 5 Tesla. So today we have learned the external point, the value of the magnetic field. From this equation we can easily calculate different types of numericals. This theory is very important in different type of board exams, and these numericals are also important for different examination purpose. Thank you all my dear students. Please like, share and subscribe.